Good day, everyone. In this presentation, I'm discussing what was done in our statistics class. All right, we had discussed central tendency and the statistical definitions. We analyzed some data and we realized two important statistical studies. All right, so we ask a question: how can we use an experiment to test a conjecture? And we realize a conjecture is making a conclusion based on experiments done. That's what we realized. So let's continue on. All right, we talked about some announcements. I told you when I assign homework to you guys, I'm gonna give you a week to complete it. Homework will include some review stuff that was done. I'm not going to assign no test unless the district gives it. So if the district don't give it, I won't test you. Because in my class, instead of test, you have projects to deal with. So let's review our statistics. All right. So far, you guys know that data is a number that tells a story. You learned in your Algebra 2 course. In every class period, I ask you about what is data. Also, we talk about statistics. It's a number that tells a story that inspires change. And these are the data analyst's definition. So these are the definition of data from my perspective. As I told you guys before, I am a certified data analyst. So I went to school for studying statistics and data, so this is what I know and what I can speak on. All right. We did discuss the precise definition of mathematics more or less, but I mainly told you to write it down. So we know that the precise definition of mathematics is the technique to explain, understand, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. So we know that's what this is about. We know this already, and we know this from the heart. But in statistics, we're going to be using inferring a lot. We're going to model patterns, of course, that arise in the environments. We're going to use pretty much all parts of this definition, except for ciphering. You will rarely cipher. All right? And I'm going to keep asking you to write this down to tell me this every single class period. All right. So this is more about statistics definition. So we, as statisticians, define statistics very differently, but they use the same keywords, though, if you notice. The precise definition of statistics is the technique of collecting, organizing, analyzing, and interpreting data to make decisions. All right? But if you go to Google, you will see statistics being defined as the branch of mathematics that deal with techniques for collecting, analyzing, and drawing conclusions from the data. Different, right? But they all mean the same thing. All right, regression. Because one thing that you guys are always going to do is to analyze data. In most instances, you're going to be dealing with, you're going to have to use regression models. So this class period, we didn't do it. And I know when I was trying to show you guys in class, it didn't quite show right, but in this video, it has what you need. So regression uses functions, which are called models from Algebra 1 and 2, to make predictions about the data. You guys know about linear functions. You guys know about quadratic, exponentials, logarithmic, rational, cosine, and sine. These are the models that you will use in this course. So again, everything that you did in Algebra 2, you're going to see it again. Alright, so let's review central tendency. So you guys know that mode is the number that occurs the most. Mean is the average number. Median is the middle number. So good job in the Kahoot. When y'all did y'all Kahoot, you guys killed that Kahoot. You guys messed up once. I was purposely trying to get y'all to mess up so hard, but you pulled through. So I know in the lesson I told you guys to input these numbers in the calculator. And when you input in the calculator, I gave you a thing of steps to input them in. Of course, you guys don't have a calculator at the house. Maybe one or two of you guys do, but most of you guys do not. So if you need to do it, here we do it. Here you are. And when you do all of that, it should look like this. This is the list where you put your data in, and you're good from there. All right. Also, to find your central tendency, you input this into the calculator, just like this. And when you do it, you get all the stuff you needed. I know one thing that I know I didn't cover in class. I did not review what this notation means. That's the average. All right. You got the median, but the thing don't show you the mode because it don't really want you to see the mode. Well, it don't want to do the mode because you could visually see that for yourself. Alright, so let's look at statistical types, not statistics, statistical types. And we know there's two types. And again, we talked about how can we use an experiment to test a conjecture, again to test a conclusion. So we're going to run through the exercise we have done already. Alright, two important statistical studies. Experimental studies or individuals are assigned at random to the treatment group or the control group. All right. And we're going to dive deep into experimental studies. Observational is when people are selected at random instead of being selected on whatever. So that's the one thing that you have to pay close attention to know the difference between experimental and observational studies. Again, experimental or individuals are assigned at random to the treatment group or the control group, so they assign to one or two groups. Observational is when when possible, random samples can be selected from the groups being studied. So again, this is just choosing what you see. All right, let's move on. All right, so when we're dealing with experiments, here's what we have to pay close to. In a controlled experiment, you're dealing with two groups that are studied under identical conditions with the exception of one variable. The group under ordinary conditions subjected to no treatment, which is the control group. But the group that is subjected to the treatment is the treatment group. So, when you talk about like drugs and placebos and stuff like that, keep that in mind because we're going to be dealing with a lot of studies about that. Experimental process. Randomizations. When we deal with experiments, it deals with randomizations. It's a process of randomly assigning subjects to different treatment groups. In the randomized comparative experiments, subjects are randomly assigned to the control group or the treatment group. In some cases, subjects in the control group are given a placebo, which is harmless, unmedicated treatment that resembles the actual treatment. Alright, this is what we talked about in class. And I told you placebo is more like a sugary pill. But again, we're going to see how this operates in our classrooms. Alright? Alright, so why don't we not look at these reports? These are published reports, and we're going to evaluate them. See, okay, what's wrong? What could be done to be how can we improve it? So let's look at the vitamin C lowers cholesterol. At a health clinic, patients were given the choice or whether to take a dietary supplement of 500 milligrams of vitamin C each day. 50 patients who took the supplement were monitored for 1 year. As the 50 patients who did not take the supplement, at the end of 1 year, patients who took the supplement had a 15% lower cholesterol level than the patients in the other groups. And we also define what cholesterol is. So we talked about how when you eat eggs too much on a daily basis, that raises your cholesterol level. So we have to be careful about eating eggs on a daily. Now, checkout. We go through this. I'll talk to you guys about how I mispronounce Rouse's a lot. To test the new design of its self-checkout, a girl gathered 142 customers and randomly divided them into groups, two groups in particular. One group used a self-checkout and one group used an old self-checkout to buy some groceries. Users of the new self-checkout were able to complete their purchases 16% faster. Alright, so first let's talk about the cholesterol. Alright, I know Castile, Sylvester, and Simmons all identified the parts of the study and the experiment. So we talked about the checkout being a randomized comparative experiment. And we was able to talk about how the control group was the individuals who used the old checkout. And then we talked about how the treatment group used the new self-checkout. So we identified those parts very well. Sylvester, Castile, and Simmons discussed that with us. So we was good on that. And there was nothing wrong with these studies so far. So there was nothing to make a crazy congestion. So it was okay. I told you guys to remember experimental studies and observational studies. Okay, now these are things that we have to remember. I told you not to write these down, but we will review them later on. So a rigorous randomized comparative experiment by eliminating sources of variation other than the control variable can make a valid cause and effect conclusion possible. But an observational study can identify correlation between variables but not causation. Variables other than what is being measured may be affecting the results. So we're going to talk more about this next class period. All right. We talked about this. Jones, Matthews, and Anderson gave us good conclusions from this, as well as everyone else. So we talked about this topic, and we had to identify this one as an experiment or observational study. And then we have to describe the design of the experiment and to know, does it make sense or not? So we wanted to know whether vigorous exercise in older people results in longer life. That's for what we wanted to know. And all of you called it out to me pretty much verbatim. And we went on so quick because I was so impressed. We talked about how the treatment of a vigorous exercise is not possible for those people who are already unhealthy. So it was unethical to assign individuals to a control group. So we was killing it. And then we talked about using an observational study and just choose a random group of people who already exercise vigorously. And then randomly choose a group of individuals who did not exercise vigorously. And we also talked about getting the ages. And we also remembered that an observational study, we are able to identify a correlation between vigorous exercise in older people and longevity, but not causality. Okay? And then we went in and talked about sample sizes. Sample size is the number of subjects in the experiments. And we did not talk about this last one. We talked about how we wanted to prove the validity of the experiment being replication is required, which is the repetition of an experiment under the same or similar condition. The validity of an experiment refers to reliability of results. The results of environmental experiments are more likely to be accepted. And I will go over this more in detail next class period. So we did talk about this. Because this is the stuff about, you know, using an experimental study to fix our conjectures, to make a conjecture. That's what we've been talking about. That was the goal of the lesson. So a pharmaceutical company wants to test the effectiveness of a new chewing gum designed to help people lose weight. Identify a potential problem, if any, with an experimental design and then describe how we can improve it. So, this is what you guys spoke to me. Alright, so right here is the details of that experiment that they just talked about. So here's the results, and we want to look and see what's wrong with it, how can we make it better. So 5 companies identified 10 people who are overweight. 5 subjects are given the new chewing gum, and 5 was given a placebo. After 3 months, each subject is evaluated, and it is determined that 5 subjects who have been using the new chewing gum have lost weight. So we got to describe what was wrong with it. And I will admit, you guys crushed this one. You guys was calling it out. You guys have told me that a sample size is too large enough to produce a valid result. So Castile called it out. It was very nice, and he gave an eloquent detail. So again, the issue is that the size is too small. You need more people. We did not talk about this, but I would like to discuss it. All right? And this is another result of that same study about the chewing gum making people lose weight. The company identifies 10,000 people who are overweight. The subjects are divided into groups according to gender. Females receive the new chewing gum and males receiving a placebo. After 3 months, a significant large number of females have lost weight. So we got to describe what's wrong with this KPI, which is key performance indicator, and how can we improve it. So the issues that we having is that the subjects are divided into groups according to gender, and the groups may not be similar. The new chewing gum may have more effect on women than on men, or vice versa. It is not possible to see such an effect with the experiment the way it is designed. The subjects can be divided into groups according to gender, but within each group, they must be randomly assigned to the treatment group or the control group. So, you guys, this is basic statistics 101. Something that we're going to be dealing with so much. We're going to be dealing with a lot of studies. And in statistics, when we say recommendations, this is our conclusions, things that we want to improve on. Alright, so that's it. Easy, shorter than the Algebra 2 video, huh?